In this video, we'll learn how a dedicated outside air system works, better known as a DOAS unit. We'll learn the different methods of delivering outside air into spaces and the various HVAC systems that work with a DOAS unit, like a VRF system, water source heat pumps, fan coils, and chilled beams. Dedicated outside air systems are used to condition all ventilation air brought into the building for the health of the occupants and as mandated by code. The outside air is either served directly to the space or in collaboration with a local HVAC system. Before we add a dedicated outside air unit, let's look at how ventilation air is normally brought into a commercial building using an air handling unit. This air handler mixes outside air with return air before entering the filter bank and then through the fan and a chilled water coil served by a roof-mounted air-cooled chiller. The important thing to note is that the air handler and chiller are sized to treat all the latent heat coming in for ventilation and internal latent loads, in addition to the sensible load. The chilled water coil in the air handler is sized to provide latent and sensible cooling. We can decouple the latent load from the sensible load by adding a DX DOAS unit. Then the air handler's chilled water coil can be downsized, including the chiller, pump, and piping. This savings is offset by the addition of another piece of equipment, the dedicated outside air system, which is dedicated to treating the ventilation air in an indirect or direct configuration, which we'll discuss shortly. If we install a DX dedicated outside air unit on the roof to handle the ventilation air and remove the outside air louver and duct from the indoor air handler, then all the latent load for the ventilation air will be handled by the DOAS unit. Then we install sheet metal ductwork to connect the ventilation air from the DOAS unit indirectly to the space by connecting to the back of the air handler. This is considered an indirect method of providing ventilation air, as the air is not delivered directly to the space, but through another piece of equipment. Since the dedicated outside air unit is handling all of the load for the ventilation air, the chiller can be reduced in size along with the air handler cooling coil, so we'll remove this large air-cooled chiller and install a smaller one. Now we'll remove the indirect ventilation ductwork and connect the DOAS ventilation air directly to the space without going through the air handler. One of the issues that the use of a DOAS resolves better than a recirculating VAV system is that of delivering the proper amount of ventilation air to each space or zone. A VAV air handler can often overventilate a highly populated space. We can also keep the same chiller and use the extra capacity to feed a chilled water coil located within a DOAS unit. The air handler's cooling coil can be reduced as it doesn't have to handle the latent load from the incoming ventilation air. The DX DOAS unit can be removed and a chilled water DOAS added to handle the ventilation air. This will require the connection of heating hot water piping to the unit as well as chilled water piping. Since all the load for the ventilation air is being served by the chilled water, the chiller needs to be upsized. A larger chiller is put on the roof to feed the load of the DOAS unit and the air handling unit. Sheet metal ductwork is used to feed the space directly. One of the main differences between this chilled water DOAS unit and the DX DOAS unit is in the method they produce dehumidification and cool air. The DOAS unit will reduce indoor CO2 levels while removing excess humidity and condensation, which reduces sick building syndrome. The DOAS doesn't recirculate indoor air back through the unit, so the air is always fresh. That is, if the outdoor air is better than the indoor air. If the quality of outdoor air isn't of the best quality, additional filtration can be added to the unit. Another system served by the dedicated outside air units is one with chilled beams. Chilled beams are considered passive or active. An active chilled beam is what we are using to cool these spaces. They contain a coil or heat exchanger in a housing suspended above the floor. A dedicated outside air unit with an energy recovery wheel is used with these chilled beams. The energy recovery wheel is used to capture energy from the air being exhausted from the space and returning this energy to the air entering the unit. Remember, the DOAS unit is 100% outside air. So that means the exhaust air volume needs to be close to the quantity of ventilation air coming into the building to avoid overpressurizing the spaces. Energy recovery is the process of exchanging sensible and or latent heat between the exhaust air and outside air airstreams. Where extreme outdoor temperatures and relative humidities exist, the use of energy recovery devices can increase energy savings by capturing the energy before it is exhausted. Using chilled beams will require the installation of a chiller, in this case an air-cooled chiller mounted on the roof and piped to the chilled beams and the DOAS unit. The ventilation air from the DOAS unit will pass through the chilled beam, inducing room air up into the center and through the cooling coil and back into the room. It's important to keep the chilled water to these chilled beams above the dew point temperature to avoid condensation, as there are no drains used on these units. Typically, the greatest dehumidification loads are from ventilation air, as removing the moisture out of the outdoor air for ventilation requires latent heat. See our video on humidification for additional explanations of humidity. The DOAS unit can provide heating, cooling, humidifying, and dehumidifying. The main purpose of a DOAS is to provide ventilation air for acceptable indoor air quality and to offset exhaust air used for bathrooms or other purposes. Removing the chilled beams and redoing the ventilation duct and chilled water piping, we can install a couple of fan coil units with connection to the chilled water piping system is another option. The ventilation air from the DOAS unit is indirectly connected to space by connecting it to the return air plenum on the fan coil. A supply grill can be installed on the ceiling to duct the ventilation air directly to the space. Using 4 pipe fan coils with a DOAS unit will separate the latent load from the sensible load. The DOAS will handle the latent load, while the fan coil units will handle the sensible load. The DOAS can deliver the supply air temperature low enough to pick up the additional room latent load also. DOAS units are often used with a VRF system. Here we have a VRF outdoor unit installed on the roof. We have a ducted VRF fan coil unit, a VRF ceiling cassette, and a VRF wall-mounted fan coil. The outdoor unit will be connected to the indoor VRF fan coils using refrigerant piping. We show a simple VRF heat pump system here, but this can also be used with a VRF heat recovery system. The dedicated outdoor air system is connected directly to the space for the VRF wall-mounted cassette and ducted indirectly to the VRF ceiling cassette and the VRF concealed ducted fan coil unit. This takes the burden of treating the ventilation air off of the VRF fan coils, which will handle the room load. The DOAS can provide heating and cooling of the outdoor air provided for ventilation. Conditioning outdoor air is energy intensive, and methods need to be adopted to avoid providing more outdoor air than is required by the spaces served. The DOAS will remove the moisture or latent heat and sensibly heat from the ventilation air, allowing any downstream equipment to focus on the space sensible load only. If you like that video, please give it a thumbs up and subscribe to our channel. Thank you.